Welcome back to another day of Section 3.4, Marginal Economics. Yesterday we talked about the cost and the marginal cost of a function. Today we're going to talk about marginal revenue and marginal profit. So marginal, as you recall, is the derivative, means our derivative. So we're going to find the derivative of the revenue. And what does it tell us? Well, it's going to tell us how much revenue that we can realize by producing one more unit. So in order to find our revenue, we're going to have to multiply the price by the number of units sold. And recall, the price is determined by the demand function. So our revenue function is going to be defined by X, which is the number of units that we sell, times P, which is our price. Or if you want to think of it as X times f of X. What we have to remember is that we're in P equals form. So we have to have our price. P stands for price. Little p stands for price. So the first thing we're going to do for example 1 here is find our revenue function. So we're going to take X, we're going to multiply it by the price, which is negative 200th X plus 400. We can go ahead and multiply that out if you want. So negative 200th x squared plus 400x. The question is asking us to find r prime of 2000. So first thing we're going to do is find r prime of x. Gives us negative 400th x plus 400. We can find r prime then of 2000. Again, I would go ahead and put that in my calculator. So we have negative 400ths. We're going to multiply it by 2,000, and then we're going to add 400 to it, and we end up with 320. So what does that mean? That means the revenue of producing, or not producing anymore, we're selling, aren't we? Of selling the 2,000 first item is $320. So that's a lot of revenue. I wonder what we're selling there. So that's what kind of the idea of what this means. So r prime, remember, is derivative, which is our marginal revenue of 2,000 items, gives us the 2,000 first items revenue. We can do the same thing for profit. Recall, profit is revenue minus the cost, so we have to have the revenue function, and we have to have the cost function. We can simplify p of x and then go ahead and find our derivative. So here we have our r of x. We're given a c of x. We're going to find p prime of 2000. So in order to find p prime, we first got to find p of x. P of x is going to be our revenue, negative 200 x squared plus 400x. And from that, we're going to subtract. Remember, when we subtract, we got to put that in parentheses. So we're going to subtract 100x plus 200,000. Our p of x then, simplified, is going to be negative 200 x squared. 400x minus 100x gives us 300x. Remember to multiply that negative through, so we get a minus 200,000. We can find p prime then of 2000. Oh, sorry, not yet. We're going to find p prime of x first, don't we? So our p prime is 400th x plus 300. Now we can go ahead and find p prime of 2000. Plugging in our 2000 there, we get negative 80 plus 320, which is going to give us 300, which is going to give us 220. I guess my brain was kind of going already ahead of me. So what does that tell us? That tells us that the profit of selling 2,000 first item, again remember it's always one more than what we found, is $220. And that gives you a little idea of now what our profit is going to be and how much profit we can get for selling one more unit. Oh, I guess I ran off the paper there. Sorry about that. So the profit of selling 2,000 first item is $220. And in example 3, we're going to throw it all together. So this is kind of like a culmination of where would we ever use all of this stuff in one problem? So here we have a weekly demand for CD players. It's given by the demand function x equals negative 50p plus 15,000, where p denotes the price in dollars, x denotes the quantity demanded. Total cost of the function, total cost function is c of x equals that big old long function. Can we find the revenue function and the profit function for part A? Well, revenue, again, is x times p, or the number of units times the price. So we have to come get the price from the demand function. In this case, our demand function is in units, or is equal to our units. So what we're going to do is solve for p. So if I solve for p, I'm going to subtract my 15,000 there, and I'm going to divide by negative 50. And that's going to be my p-value. What you can do, if you want, is go ahead and simplify that or break it up so that we have negative 1/50th x plus 300. Kind of a little nicer looking, I think, than working with this kind of uglier fraction. So that gives us our revenue function. Our profit function is taking our revenue function and subtracting off our cost function. So we have negative 1/50th x plus 300 minus that cost function. We have what, 5 zeros? Yep, 5 zeros. Who made these problems up? Wasn't me. Don't blame the teacher. Let's see, 200x plus 70,000. I didn't have to give it to you, I guess, did I? So multiply your negative through. So p of x is going to be, oh, good gracious. This one, oh, I didn't multiply my x times my p, did I? So it's x squared, and this is 300x. Whew. I thought that looked awfully odd. How am I going to subtract that? And that's not going to be much. So make sure you multiply it by x. Don't do what I did. Do better than me, I suppose would be the word of the day, huh? Let's see, we have negative 1/50th x. If I take 1 and divide it by 50, I'm going to get negative 0.02, or negative 200th x squared. So I can add that. This is going to be a positive 400th x squared, so I get a positive 200th x squared. I have 300x minus 200x, which gives me a positive 100x, and then minus 70,000. And that's going to be my cleaned up profit function. I can go ahead and... Now part B says find the marginal cost, marginal revenue, and the marginal profit. So all of these are going to be our derivatives. So r prime of x, we had negative 200th x squared, so it's going to be negative 400th x plus 300. Our marginal cost is going to be the derivative of that. 1, 2, 3, 4, 5 zeros, 9x squared minus 800th x plus 200. And finally p prime of x to give us that, which is going to be negative derivative of that. So we have 5 zeros. Let's see, 1, 2, 3, 4, 5 zeros, 9x squared plus 400th x plus 100. Part C says find the marginal average cost. Good gracious. So part C, we're going to take the cost function and we're going to divide it by x and then find the derivative. So I'm going to just come up here, divide all these by x. So this gives us x squared, so we're going to multiply the 2 to the 3 there. So this is going to be our average cost derivative. It's going to be, we have 5 zeros, and then 6x squared, minus, we had 400th x squared divided by x, which is 400th x. So our derivative is going to be just 400ths. If we have 200x divided by x, get rid of the x's, we just have 200. The derivative of 200 is 0. And then we have 70,000. Bring your x to the top as an x to the negative first. We multiply your negative 1 to your 70,000, so we get negative 70,000. X to the negative second, which we can take that to the bottom as over x squared. And that gives us our marginal average cost. And part D says find C prime of 3,000, R prime of 3,000, and P prime of 3,000. Running out of room. So, C prime of 3,000. I'll come up here on my C prime. Again, we can type that in our calculator. Make sure you get those 5 zeros in there. 9 times 3,000 squared. And to that, we're going to add or subtract 8/100 times 3,000. And then to that, we're going to add 200. So that gives us a cost function, or a cost of $41. So this is the cost of 3,000 first item is $41. The revenue for the 3,000 first. So we go to our revenue. We can go ahead and type in, we get -4/100 times 3,000. And to that, we're going to add 300. And we get 180. So that's the revenue of 3,000 first item is $180. And our profit function. So we go to our profit function. 1, 2, 3, 4, 5, 9 times our 3,000 squared. And then to that, we're going to add 400 x, so 400 times 3,000, and plus 100. And that's going to give us 139. Oh, good, it worked out. Why do I know it worked out? Because I take my revenue minus my cost. 180 minus 41 gives me 139. So the profit of 3,000 first item and a telephone is 139. So at that, that's going to end what we got today. Gives you your marginal economics, marginal profit, revenue, and I'm going to answer the phone. Good luck.